When you drive for a long period of time in an ordinary car, you must constantly hold down the accelerator pedal, and your foot can get very tired. However, when driving a car equipped with cruise control, there is no need to do this, because the cruise control system regulates the vehicle speed for you. The cruise control system will even control the vehicle speed for you when you drive up and down hills. This video concentrates on the cruise control system used in the Lexus LS400 for the US market. It is divided into the following 4 sections. First, let's look at how the cruise control system is used. The main switch and control switches are on the control lever beside the steering wheel, and the indicator light turns on and off when the main switch is pressed. The control switch has 5 operating modes: set coast, resume accelerate, and cancel. Let's try actually using the cruise control system. First, turn the main switch on. Now run the vehicle up to 40 kilometers per hour or faster, and push the cruise control lever down. The cruise control system will be set to the speed at which the vehicle is moving when you release the lever. If you wish to temporarily increase your speed, such as to pass another vehicle, depress the accelerator pedal. When you take your foot off the accelerator pedal again, the vehicle will return to the set speed. When the vehicle is driven in overdrive and it slows down, as when going up a hill, it downshifts into 3rd gear to maintain the set speed. Once the actual vehicle speed returns to the set speed again, it returns to overdrive. If you wish to increase the set speed, use the accelerate mode. Lift the control switch up, and the vehicle will pick up speed. Release your hand, and it will be set at that speed. With the LS400, each time you tap the control switch in the upward or accelerate direction, the set speed is increased by 1.6 kilometers per hour, and actual vehicle speed picks up. When you wish to lower the set speed, use the coast mode. Press the control lever down, and the vehicle slows down. Of course, you can also change the set speed by depressing the brake pedal or accelerator pedal to bring the vehicle to the desired speed, and then reset it with the set switch. If you pull the control lever toward you, operation of the cruise control system is temporarily canceled. In addition, operation of the cruise control system can be temporarily canceled by depressing the brake pedal. In a vehicle with a manual transmission, operation is also canceled when the clutch pedal is depressed. Even after cancellation, the set speed remains in the memory, so if you use the resume mode, that is, lift the lever up when you wish to drive again using the cruise control system, the vehicle will return to the set speed. However, the set speed will be erased from the memory if the actual vehicle speed falls below 40 kilometers per hour. If this occurs, the resume function will of course not operate. Let's take a look at the components of the cruise control system. The main components are the cruise control ECU, the actuator, the main and control switches, the speed sensor, and the combination meter. The cruise control ECU is located on the left cowl side panel. The actuator opens and closes the throttle valve according to the signals from the ECU. The speed sensor generates a signal depending on the speed of the vehicle. 20 pulses from the speed sensor are converted to 4 pulses in the combination meter and sent to the ECU. In addition, the stoplight switch, the neutral start switch, and the parking brake switch can be considered component parts of the cruise control system because when any of these switches go on, operation of the cruise control is canceled. Now let's look at the operation of the cruise control system. There are 2 types of actuators, a motor-driven type and a vacuum-driven type. The actuator used in the LS400 is the motor-driven type. The motor-driven type actuator is made up of a motor with a safety magnetic clutch, a potentiometer, a control arm, and so on. The function of the safety magnetic clutch is to connect and disconnect the motor and control arm as necessary. When the cruise control system is switched on, the clutch engages, connecting the motor and control arm when electrical current flows from the ECU. Also, when the brake pedal is depressed, or when the ECU senses a malfunction in the cruise control system, current to the safety magnetic clutch is interrupted, and the clutch disengages, breaking the connection between the motor and control arm. The motor rotates in both directions, so it can control both acceleration and deceleration of the vehicle. In addition, there are 2 limit switches built into the motor to protect it. When the system is not operating, the limit switch on the MC side is closed, and that on the MO side is open. When the motor begins to rotate in the acceleration direction, the switch on the MO side closes. When the throttle is fully open, the switch on the MC side opens and motor rotation stops. When the motor begins to rotate in the deceleration direction, the switch on the MC side closes. When the throttle is fully closed, the switch on the MO side opens and motor rotation stops. The control arm is connected to the throttle valve via cables. When the vehicle is not being controlled by the system, the cruise control cable is free. On the other hand, when driving with the cruise control system, the cable connected to the accelerator pedal is free. The potentiometer detects the opening angle of the control arm. The signal output by the potentiometer is used to control the motor and to monitor the control arm position for the self-diagnostic function. Next, let's look at the operation of the cruise control system by means of a circuit diagram. When the main switch is turned on, current flows to the relay in the ECU, and the ECU begins to sense the vehicle's speed. However, current does not yet flow to the actuator motor and safety magnetic clutch. The speed is set in the ECU's memory when the set switch is pushed and released. At the same time, the safety magnetic clutch is activated and motor rotation is transmitted to the control arm and potentiometer. At this time, the potentiometer sends a signal to the ECU according to the opening angle of the throttle valve. Speed can be set anywhere in the range between 40 and 200 kilometers per hour. The ECU compares the actual vehicle speed sent from the speed sensor with the set speed and opens or closes the throttle valve accordingly. For example, if the actual vehicle speed falls below the set speed, it opens the throttle valve, while it closes the throttle valve if the actual vehicle speed exceeds the set speed. By continuously performing this operation, the cruise control system keeps the vehicle at the set speed. When the vehicle is driven up a hill, its speed will fall. When this occurs, the cruise control ECU sends a signal to the engine and transmission ECU, ordering it to downshift to third gear in order to keep the vehicle at the set speed. When the vehicle returns to the set speed, the transmission upshifts back into overdrive. Remember that when the cruise control system is operating while the ECT is operating in the power mode, the ECT is automatically switched to the normal mode regardless of the status of the driving pattern select button. In the accelerate mode, the actuator motor rotates in the acceleration direction and speed is increased. When accelerate is turned off, the ECU saves the speed at that moment in its memory as the set speed. In the same way, in the coast mode, the actuator motor rotates in the deceleration direction and speed is reduced. When coast is turned off, the ECU saves that speed in its memory as the set speed. When the control lever is pulled toward cancel, the cruise control ECU immediately releases the safety magnetic clutch in the actuator to stop operation of the cruise control system. At the same time, it rotates the motor to fully close the throttle valve. The cruise control system is also stopped in the same way when a cancel signal is received from the stoplight switch, the neutral start switch, or parking brake switch. There are actually two switches in the stoplight switch, which control two different functions at the same time. One switch goes on when the brake pedal is depressed, not only to turn on the brake lights, but also to tell the ECU that the brakes have been applied so that the ECU can stop operation of the cruise control system. The other switch mechanically cuts the circuit between the actuator's safety magnetic clutch and the ECU and disengages the clutch to stop control by the cruise control system. At this time, the set speed is still saved in memory so that the original set speed is resumed if the resume switch is turned on and then released. Once the actual vehicle speed falls below 40 kilometers per hour, operation is canceled and the set speed is erased from its memory. In addition, if the actual vehicle speed falls 16 kilometers per hour below the set speed while the cruise control system is in operation, operation of the system is canceled and the set speed is erased from its memory. The resume function is not effective at this time. The foregoing has been an explanation of the motor-driven type actuator. Now let's take a short look at the operation of the vacuum-driven actuator. The vacuum-driven actuator has a control valve, a release valve, a diaphragm, and a return spring. The control valve is used to draw either atmospheric air or vacuum into the actuator. When current flows to the control valve, the passage through which atmospheric air flows is closed, and the passage for intake manifold vacuum is opened, creating a vacuum in the actuator. When the strength of the vacuum exceeds the force of the return spring, the diaphragm moves inward. As a result, the throttle valve connected to the diaphragm via a cable is opened and the vehicle accelerates. When current flow to the control valve stops, atmospheric air enters the actuator. The diaphragm is therefore pushed back by the return spring and the throttle valve is closed. The strength of the vacuum in the actuator is regulated by the length of the time that the current flows to the control valve. The ECU compares the actual vehicle speed with the set speed and varies the ratio of time that this current flows in order to regulate the opening angle of the throttle valve. When operation of the cruise control system is canceled, the release valve lets atmospheric air into the actuator, causing the throttle valve to close instantly. When current flows to the release valve, the passage for the flow of atmospheric air is closed. When the operation of the cruise control system is canceled, current to the release valve, control valve stops and atmospheric air enters the actuator. As a result, the diaphragm is pushed back by the return spring and the throttle valve is released. The cruise control system has a self-diagnostic function. If no signal comes from the speed sensor and the ECU detects a system malfunction, cruise control system operation is canceled and the indicator light blinks 5 times, then turns off in order to inform the driver of the system malfunction. The cause of the malfunction is saved in the memory of the cruise control ECU. At this time, the cruise control system does not operate even if the main switch is turned on. However, once the ignition switch is turned off and then on again, the system will operate when the main switch is pressed again. The cruise control ECU of the LS400 has a backup power source, so the cause of the malfunction will remain in the ECU memory even if the ignition switch is turned off. On other models, it is erased when the ignition switch or main switch is turned off. With the ignition switch on, connect terminals TC and E1 of the TDCL or check connector. This will allow you to find out the cause of the malfunction by counting the number of times the indicator light blinks. Here you see codes 12 and 13. Code 12 means open circuit in the safety magnetic clutch, and code 13 means potentiometer output signal is abnormal, or open circuit in the motor output circuit. Let's check the actuator. As you can see, the connector is not connected. After remedying this, remove the dome fuse to clear the memory. Now look at the diagnostic codes again. The normal code is now shown. The cruise control ECU also has an input signal check function. Let's take a look at that now. This function checks whether or not signals for all control switches and the stoplight switch, parking brake switch, neutral start switch, and speed sensor are being input correctly into the ECU. Let's try it. Turn the ignition switch on and turn on the main switch while pushing the control lever down, that is, turning on Set Coast. At this time, the power indicator light blinks twice. This sets the ECU in the input signal check mode. First, pull the control lever toward cancel and hold it. If there is no malfunction in the cancel switch circuit, the power indicator light will blink once. And it blinks twice when you push the control lever towards Set Coast. Next, it blinks 3 times when you push the control lever toward Resume Accelerate. It blinks 6 times when the brake pedal is depressed. Next, jack up the vehicle and start the engine. If everything is normal, the light blinks 7 times since the parking brake has been depressed. When we release the parking brake, it blinks 8 times. The reason for this is that the shift lever is in the N or P range. If we shift to the D range, it remains lit. When we drive at 40 kilometers per hour or faster, it begins blinking. So the speed sensor circuitry is normal. When the main switch is turned off, the input signal check mode is canceled. The foregoing was an input signal check. The LS400 also has a cancel signal check function. The ECU stores the cancel signal that last canceled the operation of the CCS. So you can find out the cause of the cancellation by checking which cancel signal is in the memory. Let's try it. Turn the ignition switch on. Then turn the main switch on while pulling the control lever toward you. The cancel signal is indicated by the blinking pattern of the power indicator light. This blinking pattern means that operation of the system was canceled by the stoplight switch signal. If the main switch is turned off, this display disappears. Now let's take a look at the cruise control system checker. The CCS checker can be used for off-vehicle diagnosis. It can be used to check the operation of the power supply, the main switch, the indicator light, the input signals, and the actuator. Let's look at the circuits that can be checked on the diagram. First is the power supply. The circuit from the battery to the ECU battery terminal, and the circuit to the ECU STP Plus terminal can be checked. Next is the main switch. The circuit from the ECU CMS terminal to the ground point can be checked. And then, with the ignition switch on, the ECU B terminal circuit from the battery can be checked. For the indicator, the circuit from the battery to the ECU PI terminal via the cruise control main indicator light can be checked. For input signals, checks of the circuits of the cruise control switch, the stoplight switch, the neutral start switch, and the parking brake switch, and of the speed sensor signal circuitry, and so on, can be made. On-board diagnosis of the actuator circuit is not possible. So here we'll check it using the CCS checker. First, remove the negative battery terminal. Next, disconnect the wire harness from the cruise control ECU and connect the sub-wire harness to the wire harness. Lay the LS400 checker sheet over the CCS checker and connect the sub-wire harness. Now connect the negative battery terminal, and that finishes our preparations. First, make an LED check to see if the checker itself is okay or not. Set the LED test switch to test. If all LEDs light up, it is okay. Now check the operation of the motor and safety magnetic clutch. Turn the ignition switch on. Confirm that the RPM switch is in the off position and set the continuity switch to check. If the S clutch and motor LEDs light up at this time, the circuit is normal. Next, start the engine and check the operation of the motor and safety magnetic clutch. With the RPM switch set to up, they are normal if the engine RPM increases. When it is set to down, they are normal if the engine RPM falls. Be careful. The tachometer does not go into the red zone when doing this test. Next, check the operation of the motor, potentiometer, and safety magnetic clutch. When the RPM switch is set to up, the operation of the actuator is normal if the actuator lever opens the throttle valve and the checker LED gradually grows brighter. When it is set to down, they are normal if the actuator lever closes the throttle valve and the checker LED gradually grows dimmer. Next, set the RPM switch to up, then turn it off. If the actuator lever suddenly closes the throttle valve when you do this and the checker LED goes out, the motor, potentiometer, and clutch are normal. This ends the checking of the operation of the actuator using the CCS checker. In this video, we learned how the cruise control system is constructed, how it operates, and how the diagnostic system works.